So this is our first example for stress and strain. In the clevis shown in the figure, determine the minimum bolt diameter and the minimum thickness of each yoke that will support a load 55 kN without exceeding shearing stress of 70 MPa and a bearing stress of 140 MPa. So this is our system. This is a joint connection using a clevis. Ito yung clevis. This is our plate. So, in tension, ang ating applied load na 55 kN. So, the plate and the clevis are joint connected by bolts. So, isang bolt lang yan. So, with this system, ano-ano yung mga possible failures o ano-ano yung mga limit states natin? So, stresses na pwedeng ma-experience ng system. Since may applied tayong tension, saan siya dadaan? Siyempre, dito sa cross-section ng ating plate. So, our plate will undergo tension yielding. So, meron kang tensile stress. So, magta-travel ang stress na yan para makalipat dun siya dun sa clevis. Dadaan siya dito, papasa siya sa bolt. So, pag pumunta siya sa bolt, anong mangyayari sa bolt natin? Hihila to, hihila din iyon. So, mag-shear itong area dito. And note, dalawa ang area na yon. So, what does that tell us? Meron kang two shear planes. Dalawang shear plane mo. So, gaya ng tanong kahapon, meron bang bisa ito at ito? So, wala silang bisa. They are for stability or para magstay safe lang yung hindi kumalas. Pero hindi sila napasahan ng load eh. Hindi yan nakakonect sa plate natin. So, hindi yan magdadala ng load. Hindi sila mag-a-add ng shear plane. So, nandito lang yung shear plane mo kasi nandito yung clevis na pupuntahan niya at nandito yung clevis na pupuntahan niya. So, since may dalawang shear plane, maghahati ang dalawang ito ng load. Kung may P ka dito, ang dadaan dito half na lang ng P and then dito half na lang ng P. Since symmetrical yung ating clevis. So, that is by shearing ng bolt. Sa bolt yan na. And then, pag nakalampas na sila sa bolt, pupunta na siya sa clevis. So, pag dumaan yan dito sa clevis, ano ang stress o nangyayari dito sa load natin? Anong stress ang ginagawa niya sa clevis? So, may tension siya dyan. Normal force. So, nag-tension shearing siya dyan. Tension stress siya doon. So, may tension stress ang yoke natin. Ito, yung una, tension stress ng plate. And then next, ano pang nangyari dito? So, para hindi, kapag humila to, para hindi sila kumalas, may bolt, diba? So, anong nangyayari sa bolt? Pinipress niya yung mga sides na to para hindi kumalas, diba? Para hindi ito mag-break, kailangan mas satisfy yung bearing stress. Dito nangyayari yung bearing stress natin. So, may bearing stress ang plate, may bearing stress din ang yoke or yung clevis natin. So, may bearing stress ang plate, may bearing stress ang yoke. So, yan ang lahat ng mga stresses na mararanasan ng system natin. Now, ano sa mga to ang i-check natin? So, check-in mo lang yung hinihingi ng problem, which is yung sa shearing stress and bearing stress. At sabi niya, sa yoke lang ang hinihingi niya. Yun lang ang hinahanapan niya eh. So, hindi mo kailangan i-consider yung plate na to. So, alisin mo to. tension ng yoke, di kailangan kasi hindi naman niya binigay. Di niya pinakonsider ang tension yielding ng yoke. So, eto lang ang checkan mo, stresses. Stick ka na lang dyan. So, unahin natin ang shearing stress ng bolt. So, shearing stress ng bolt equals P over A. So, ano ang stress ng kaya ng anong shearing stress ng bolt? It is 70 MPa. And then, ano yung P over A natin? Ano yung actual na dadalhin ng bolt? Since 2 shearing plane siya, maghahati nga yung ating load. So, 0.5 ng 55 kilonewton. Convert na natin siyang newton para consistent ang units natin. And then, what is the shearing area? Of course, ito yung shearing area. That is the cross-sectional area ng bolt, which is circular. So, ano ang area ng circle? Edi pi r squared. So, let's isolate r since siya yung kukunin natin. So, r will be 0.5 times 55,000 all over 70 MPa and then pi. Since naka-squared ang ating r, kailangan natin itong i-square root. And this will be equal to 11.18 mm. So, since radius yan, kunin mo si diameter by multiplying your radius sa dalawa. So, this is 22.365 mm. So, nakuha na natin yung una, no? Diameter ng bolt. Next, minimum thickness. So, gamitin natin itong bearing stress. Baka dito natin makuha ang thickness ng yoke. So, P over A. Ano ang bearing stress natin? It is 140 MPa. And then, what is our axial? So, bearing stress ng yoke, nandito yan. So, dalawang sides din. So, i-divide mo, maghahati ang ano yan, ang load into 2 is 1/2 sa isang yoke. And then, 1/2 din dun sa kabila. And then, what is our bearing area? So, since nandito ang bearing, cut natin to para makita ang bearing area. So, ito na lang pakita nating side. Pakita natin yung dalawang side na lang mamaya. So, pag sinection mo yan, ito ang magiging itsura. Since pahiga yung bolt, edi paghiga yung bolt natin dito. Then, dito ilalagay yung bolt. Dito siya nakalagay. And then, isang buo ito. So, this is our clevis. And ito yung yoke niya. Left and right. So, ano yung bearing area natin? Saan ito, diba? So, kung titingnan natin yung isang side, this side naman, yung kabila, ang magiging itsura niya ay, at dito nangyayari yung talagang bearing. Dito nakalagay yung bolt. Dito nakahiga ang bolt or ito yung pinipress na area ng bolt niyan. And then, the consideration ng bearing area is this one. So, ano ang mga variables na yan? This is yung thickness na hinihingi. This is the thickness ng yoke. And then, ito yung nakuha nating diameter ng bolt, which you also can see mula dito. And then, thickness, and then thickness. Okay? So, let's write the area o ng bearing ng yoke is D times T. Since nakuha na natin yung D kanina, isolate lang natin si T. Siya na lang ang unknown. So, T will be 0.5 by cross multiplication na times 55,000 over 140 times D. So, substituting yung value ng D dito, which is 22.365 mm. Our T is equal to 8.78 mm. So, nakuha na natin yung dalawang pinapahanap ng problem. Next problem. So, as you can see, this is a concurrent force system. So, determine the largest weight that can be supported by the two wires shown. The stresses in wires AB are not to exceed. AB is 100 and then AC is 150 MPa, and then the cross-sectional areas, AB is 400 and then cross-section of AC is 200. So, since syempre we want this in equilibrium, mag-uumpisa kasi talaga tayo sa equilibrium. And since concurrent forces, dalawang summation of forces ang pwedeng gamitin doon. Since concurrent. So, summation of forces along X is equal to 0. So, 0 is equal to, let's call this TAC, and this is TAB. TAC is going to the right, so positive cosine, since X horizontal forces tayo, and then TAB is going to the right, so negative, and then cosine 30 components. So, sila lang dalawa ang involved dyan. Let's isolate si TAC nga. TAC is equal to TAB cosine 30 over cosine 45. Let's just simplify this equation. TAC is equal to 1.2247 TAB. So, let's call this equation 1. So, summation na tayo ng forces sa Y. So, equal to 0. Upward si TAC. So, positive sine 45. And then, positive din si TAB. So, sine 30. Negative si W. So, wala nang naiwang force. So, ilipat natin sa other side ng equation, si TW. And then, gawin ko numerical coefficient yung dalawa para mas simple lang siyang tingnan. So, sine 45 0.707 TAC plus ang sine 30 ay 0.5 TAB. So, let this be equation 2. So, substitute natin si equation 1 to equation 2. So, equation 1 in equation 2. So, W is equal to, si TAC ang papalitan, 707, 1.2247 TAB. So, simplify natin dito. Let's join together si TAB. Simplify natin ang equation. So, W is equal to 1.366 TAB. So, let's call this equation 3. So, simula pa lang ng problem, we have 3 unknowns. Ito, ito, at ito. And then, we only have 2 equations of equilibrium. So, from this point niyan, wala na tayong ibang equation na magagamit. Let's just use yung mga stresses. So, ibig sabihin, at this point, nagde-design tayo. So, pag sinabi nagde-design, pipili tayo ano ang pag-govern natin na stress. Ibig sabihin, yun yung pinakamaliit para safe tayo, di ba? Kasi kung gagamitin mo yung mas malaki, mag-fail yung isa. So, let's check stress AB. Ano ang kayang action ng member AB, ng wire AB? Okay. So, stress AB natin is 100 MPa. So, force over area What is our force? Siyempre, yung tension AB. And then, anong area ng AB? It is 400. So, our tension sa AB is 40,000 Newton since MPa ito. And then, area natin is in mm squared. So, let's check ano ang kaya ng AC. Ano ang stress na kaya niya? 150 MPa and then P over A. What is the force sa member AC? Siyempre si TAC. Ano ang area niya? It is 200. So, our TAC is equal to 30,000 Newton. So, itong dalawang force niya, pipili tayo. Ano yung gagamitin natin? Kailangan nating i-compare, ipakita na mas magfa-fail yung isa and then the other will pass para mapatunayan na pili natin yung tamang actual or tamang member na mag-govern. So, gamitin muna natin si tension. Sino muna? Substitute natin itong number 4 or si TAB into equation 3, which is this one. So, substitute natin si TAB, equation 4, in 3. So, W equal to 1.366 TAB, wherein TAB natin is equal to 40,000. This is equal to 64 Newton. What if yung isa naman, si TAC, sabihin natin 5. So, 5, substitute natin in 3. So, equation 3 is W equal 1.366 TAB. So, equation 5 is TAC. Let's substitute or use an equation with TAC dito. So, gamitin naman natin si TAC naman sa equation 3. But, equation 3 is in terms of TAB. So, kunin natin yung equation na na-express ang W into TAC. Using equation 1. Nandito yung relationship ng TAC at TAB. So, kailangan natin is TAB ang isolated para in terms of TAC. So, ito yung isa-substitute natin dito. So, TAC over 1.2247. So, this is equal to and TAC is equal to 30,000. Substituting 30,000 dito. This is equal to 33,461.2 Newton. So, may dalawa tayong nakuha na weight. Mas malaki yung isa. Kapag ginamit natin ang mag-govern ay si TAB. At ang mas maliit na weight ay kapag gagamitin natin si TAC. So, ibig sabihin, hindi kaya ni TAC, no? Ang mas mabigat na load. So, ang mag-govern yan, ang magiging weight na gagamitin is 33,461. So, kung ito yung weight, ano mga corresponding value ng TAC at ng TAB? Ayun na nga, ito na si TAC. TAC ang nag-govern, ang ginamit natin, which is 30,000 Newton. So, ano naman ang magiging value ni TAB? Yung ginamit natin na to from equation 1. Let's get TAB. So, TAB is 30,000 divided by 1.2247. So, ang TEB natin is 24495.79 Newton. So, kung kukunin ng, kunwari, papakuha ko ang stress sa TAB. So, ito yung actual niya over yung area niya na 400. And then, the stress sa TAC is 30,000 divided by 200 na cross-sectional area niya. So, third example, part of the landing gear for a light plane is shown in the figure. Determine the compressive stress in the strut AB caused by a landing reaction na 20 kN. Strut AB is inclined ng 53.1 degree from line BC. So, neglect the weights of the member. So, unang-una, meron tayong strut AB, this one. Then, may landing reaction na 20 kN. So, since kunwari, ang airplane maglalanding, may dalawang gulong yan dito. Siyempre, kapag lalanding yan, ang ideal is sabay na drop yung gulong on flat na road ng daanan ng airplane natin. So, syempre, ibig sabihin, ganyan ang reaction nun. So, the given gave us 20 kilonewton na landing reaction sa gulong niya. So, nandito yung 20 kilonewton. So, ilagay natin 20,000 newton. And then, AB is inclined ng 53.1 degree from line BC. So, determine the compressive stress sa strut AB. So, compressive stress, ibig sabihin, ganyan ang itsura ng ating force. So, ito yung force natin. Compression siya. Let's call it PAB. And then, may given na dimensions. So, ano ang equilibrium natin? Of course, we want this system to be in equilibrium. Pwede tayong mag-summation of forces. Kaso, pag mag-summation of forces tayo, meron tayong point C, merong isang element dyan. Ibig sabihin, meron force na nasa member na to. So, magsa-summation of forces, and may madadagdag na unknown. So, maganda mag-summation of moment. Kasi pag summation of moment at point C, pwede natin ma-zero ang moment dito. Hindi involve ang mga forces. So, mag-summation of moment tayo sa C equal to 0. So, 0. As you can see, pin-connected siya. Yung symbol niya, no? Pin-connected. That's why, pwede kang mag-moment sa C na 0 at walang moment sa point C. So, let's do yung summation of moment. Ang forces natin is ito at ito. Of course, yung horizontal component nito dadaan sa point C. So, neglect mo yun. Vertical lang ang magkukos ng moment about C. So, 20 kilonewton is clockwise. So, negative 20,000 times ano ang moment arm niya from this point hanggang point C. It is 200 plus 450 mm. So, 650 mm. So, next force natin is PAB. Yung vertical component lang niya. And it is counterclockwise. So, positive PAB. And then, sine 53.1 ang angle niya. Ano ang moment arm? It is 450 from point C. So, wala na, no? Kasi neglect the weights of the member. So, let's isolate PAB. May makukuha tayong force. At siya lang ang variable sa equation na to. Our PAB is 20,650 divided by 450 and sine 53.1. So, our PAB is equal to 125.35 Newton. So, nakuha na natin yung compressive force niya. So, madedetermine na natin ang compressive stress. Yun ang pinapakuha ng problem. Compressive stress, AB. So, that is force over area, wherein our force is ito, 125.35 Newton. And then, ano yung area of AB? So, may binigay siya dito. It is a tube. Hollow tube siya. So, i-reduce natin yung internal diameter. So, that will be, area niya is pi d. Ilagay ko muna yung formula, no? Over 2 squared minus pi internal diameter squared. So, 36, 125.35 Newton all over pi, ano yung diameter? 40 divided by 2. And then pi, it's 30, so 15 squared. So, ang stress natin is equal to 67.71 is the 65.71 MPa. That is the compressive strength sa strut AB. Okay, so example number 4, we have a wooden block. A rectangular piece of wood, 50 mm by 100 mm in cross-section is used as a compression block, as shown in the figure. Determine the actual load P which can be safely applied to the block if the compressive stress in the wood is limited to 20 MPa and the shearing stress parallel to the grain is limited to 5 MPa. The grain makes an angle of 20 degree with the horizontal as shown dito. Okay, so we have the rectangular wood. Ang section niya is 150 mm. So, meron siyang compressive stress which is 20 MPa. So, itong 20 MPa, hindi siya dun sa parallel to the grain. It is the compressive stress of the wood lang mismo. At this section. Itong 5 MPa, this is the shearing stress parallel to the grain. Ito yung shearing stress dito. So, hindi binigay ng problem yung compressive stress or compressive strength ng wood on this inclined plane. Ang binigay niya na 20 MPa is the stress doon sa flat plane niya. Okay? So, kunin daw natin yung maximum load P, wherein masasatisfy natin yung compressive stress on this area na 20 MPa and yung shearing stress dun sa parallel sa grain dito sa inclined plane na to, masatisfy ang 5 MPa na shearing stress. So, let's do first yung compressive stress. So, dalawa ang limit states na gusto niyang ipacheck. Compressive stress. So, compressive stress na to is equal to 20 MPa. So, stress is equal to P over A. So, ano yung P dyan? The P is unknown. So, it's P. And then, ano yung area sa compressive stress na to? Yun ngang flat dito. Dito. So, the area doon is yung given na 50 by 100. So, this is 100. Ito yung 50. Yun yung area for this 20 MPa na compressive stress. So, how much is this? So, our P, ang makukuha nating P, isolate natin si P. P is equal to 50, di 10,000. So, P, isolate natin si P. Let's get P. P will be equal to 20 times 50 times 100 by cross multiplication, okay? So, that is equal to 100,000 Newton. So, ito yung ating P dahil sa compressive stress limit na 20 MPa. So, let's check kung ano ang P na kayang dalhin dun sa parallel sa grain na shearing stress. So, our shearing stress is limited to 5 MPa. And then, P over A. Ano ang P natin? Our P cannot be yung P na ito. Hindi siya pwede. Kasi this P is, hindi siya parallel sa grain. Kapag nandito si P, ilipat mo dito ang P, hindi siya parallel. Kasi dapat ang kailangan nating P for shearing stress is yung ganito, PV, parallel to the plane. So, how do we get PV? Kunin natin ang incline. So, this is 20 degrees. And then, ito yung P. And then, parallel sa plane ang kailangan natin na force for the shearing stress check. So, how to get the angle kung 20 degrees din dito. Since this is perpendicular, 90 degrees ang angle between them. So, with that, ano dapat ang angle dito? It is 90 minus 20 degrees, so 70 degrees ang angle between PV or the plane and the force P. So, we can write an equation that PV is equal to P cosine 70 since horizontal component. So, we are trying to solve yung P. So, ito ang gamitin natin equation. Ito ang ating P value. So, let's substitute. 5 is equal to P, which is cosine 70 over our shearing area. So, saan ang shearing area natin? Since ang plane natin is naka-inclined na, hindi na 100 yung ating length ng area. Hindi na ito. Ang kailangan natin na length is yung inclined length na. So, nandito siya. Ito ang kailangan nating inclined plane. So, how do we get that? So, triangle tayo. This is 20 degrees. Ito yung 100 na adjacent side ng 20 degrees. And hinahanap natin yung bagong length na to. Ito yung length ng plane natin. So, you can use cosine 20 equal to adjacent. That is 100 and the hypotenuse is x. So, we can get x. X is equal to 100 over cosine 20. So, x is equal to 106.42 mm. Yan na yung length natin. So, nandito yan, 106.42. So, our 50 dito, yung side na to is still 50. Hindi siya nagbago. Hindi naman siya na-slice. So, 50 pa din siya. So, ano na ang ating shearing area? It is 100. Ito na siya. 106.42 by 50. So, 106.42 times 50. So, let's isolate P. P will be 5 times 106.42 times 50 divided by cosine 70. Our P is equal to 7787.816 m. Yun yung P dahil sa shearing stress limit natin. And this is P dahil sa compressive stress limit natin dito. So, anong magagawin? Siyempre, yung mas maliit, since magfe-fail ang ating shearing stress kapag 100 ang load na P natin. Number 5 example. As in the figure shown, a hole is to be punched out of a plate having an ultimate shearing stress of 300 MPa. If the compressive stress in the punch is limited to 400 MPa, determine the maximum thickness of the plate from a hole 100 mm in diameter can be punched. So, 100 mm yung diameter for situation A. Hahanapin yung corresponding thickness naman ng plate. So, check natin yung compressive stress. So, binigay ng problem is compressive stress and shearing stress. So, ibig sabihin, ito yung limit states natin. So, compressive stress, P over A. So, ito yung compressive stress and is limited to 400 MPa. So, may makukuha tayong P dito. Since compressive is nangyayari dito, kinocompress niya ang cylindrical block. So, ito yung force natin na P. So, ano ang area nito? This is our compressive area. So, since given ang 100 dito, 100 mm, makukuha natin ang area na yan. So, it is pi r squared. So, diameter to. So, 50 ang radius squared. So, our P, computing this one. So, 400 times pi times 50 squared. Our P is equal to So, yan ang compressive stress with 100 mm diameter and yung compressive limit na 400 MPa. So, next natin titingnan is yung shearing stress. Shearing stress, syempre P over A pa rin yan, wherein shearing stress limit natin is 300 MPa. What is our P? So, since ito yung maa-apply na P dito, ito rin yung ito rin yung source ng shearing. And then, nasaan naman nangyayari yung shearing natin? So, ito yung mag-shear. Itong buong dito. Itong circumference at yung gilid ng cylinder na punch out. Okay? How do you get yung area ng shearing na to? It is yung circumference ng circle which is pi d times yung thickness. So, ito yan. Itong buong circle na to na may thickness which actually is missing sa problem. Pinapahanap niya yung thickness for a 100 mm diameter. So, the same pa rin, our P will be 31, 41, 59.2.65 Newton all over. What is our area? It is the circumference na pi d times yung thickness. D is given, it is 100 mm. So, ang missing lang natin dito is T. Let us isolate T. So, T is equal to 3141592.65 Newton divided by 300 pi, and then D is 100 mm. So, consistent ang units. So, our T is equal to 33.33 mm. Ngayon, sa situation B, if the plate is 10 mm thick, so, erase muna natin to. Ang plate is 10 mm thick. Ano daw ang magiging diameter? Ito na yung missing. So, ito yung diameter. Ito na yung missing natin. So, diameter exists sa compressive stress check and shear stress check. So, kailangan natin daanan ulit yung dalawa. So, compressive stress na P over A is equal to 400 MPa. Wala tayong P dito. And so is diameter. So, isolate natin si P. It is 400 pi D over 2 raised to but 4 raised to 2. Then, let's check C. Shearing stress, P over A pa din yan, wherein our stress is 300 MPa equal to, ano yung force natin? Same pa din, same force yan. Mag-iiba lang yung shearing area. Our shearing area is circumference pi d times thickness. Given yung thickness, substitute na natin, it is 10. So, isolate natin si P, 300 times pi times d times 10. So, these two equations are both equated to P. So, pwede natin silang i-equate to each other. So, equate natin sila each other. P is equal to P. So, 400 pi d squared over 4 equal to 300 pi d times 10. So, mag-cancel tayo. Let's simplify the equation. 400, di 100 na lang to. Pi d squared. And then, multiply natin ito and ito. That is 3,000 pi d. Both sides of the equation have d. So, pwede tayo mag-cancel. Both equations also have pi. So, pwede na natin cancel yon. So, divide both equation by pi and d. So, cancel to, cancel yung isa, cancel tong dalawa. Our remaining equation is 3,000. So, our d is equal to 3,000 divided by 100. So, it is 30 mm. This is our d. Ito na yung d natin. It is 30 mm. Okay, next example. A joint is made by gluing two plywood gussets of thickness T to wood boards. The tensile working stresses are 2 psi for plywood and 700 for the boards. The working shear stress for the glue is 50 psi. Determine the dimensions B and T so that the joint is as strong as the boards. So, the joint is as strong as the boards. So, ibig sabihin, kailangan natin gamitin yung kayang P ng board. Ito kasi yung board. These are the plywood. So, let's get ano ba ang kaya ng strength ng mga board. Ano yung tensile stress ng board? It is 700 psi. So, stress ng board is 100. 700 psi. That is equal to force over area. So, ito yung kailangan natin kung ano yung kaya niyang actual force. So, ano ang area niya? Siyempre, yung cross-section niya dito. Yung rectangular cross-section niya dyan. So, height niya is 1.75 given dito inches and width niya is given dito 5.75 inches. So, 700 psi is equal to P ng board over area na 5.75 times 1.75. So, units are uniform, PSI to, inches yung dalawa. So, our P na kaya ng board is pounds. So, ibig sabihin itong actual force na to dapat kaya ng ibang stresses sa ibang parts ng system natin. Ano yung ibang stresses na nangyayari? Meron kang tension yielding sa board, which is what we've done na, tension yielding sa board. Meron kang shearing stress dun sa glue. And then, meron kang tension ulit sa plywood. So, let's check. Ito yung mga limit states niya. Tension ka dito. So, magta-travel siya doon. Maghahati sila. 1/2 P dito. 1/2 P din sa baba. Then, para maka-transfer, kailangan nilang dumaan sa shearing stress ng glue. And then, pag nakalipat na sila, magte-tension ulit naman si plywood. So, itong tatlo lang. So, we've done yung tension ng board. So, let's go sa shearing ng glue. So, shearing ng glue is equal to force over area. So, ano yung force? Since dalawa ang plane natin, dalawa yung plywood, top and bottom, so, shear plane is 2. So, 1/2 P. So, 0.5 ng P, wherein ang gagamitin nating P is ito, kasi nga gusto niya, kung ano yung strength ng ng board, siyang strength ng iba pang part ng system natin. Over, ano ang area natin for shearing? Siyempre, kapag mag-a-apply ka ng glue, saan mo yun ipapahid? So, dito ka magpapahid ng glue. Siyempre, isang side yan. And then, siyempre, yung kabila, naka-glue din. So, pero ang i-consider mo is yung isang side lang. Then, naghahati yung dalawa, top and bottom. So, our area is 7 point, ito mismo, itong area na to, 5.75, and si B, which is missing. So, it is 5.75, and then B. B is the only unknown, so we can isolate. So, B will be 0.5, 7043.77 to. Pounds all over yung shear stress ng glue, which is 50. Ito, shearing ng glue is 50. So, 50 times 5.75. Okay na. So, perform the operation. So, 0.5 times 743.75 all over 50 times 5.75. It is 12.25. So, nagamit na natin si glue. Punta na tayo sa tension yielding ng plywood. So, tension yielding ng plywood, force over area. So, ano yung tension yielding ng plywood? It is 12 PSI. Ano ang actual mo? Sabi nga niya, ito ang gagamitin. 75 LB all over. Ano naman ang area para sa plywood? Ito siya. Ano yung area na yan? Yung rectangle. And then yung missing na T. And then ito pa din yung lapad. 5.75. So 5.75 times T. So T is the only unknown. You can isolate para makuha mo yung value ng T. Dito na nga lang. So T, 7043.75 divided by 1 to 5.75. So, doing the operation, you will get T na equal to 0.510 inches. Ito and ito. Okay. So, next example. So, number 7. So, ito yata yung paborito ninyo. So, i-review pa rin natin kasi, syempre, not everyone, no, gets. So, the lap joint is connected by 3 20 mm diameter na rivets. So, you expect na maghahati-hati yan sa load na P. So, assuming that the actual load is 50 kN distributed equally among the 3 rivets, find the shearing stress in the rivet, find the bearing stress between the plate and the rivet, and then get the maximum average tensile stress in each plate. So, identical naman yung ating plate. So, isang tensile stress lang yan. And where does it happen, yung tensile stress? Siyempre dito, yung rectangular cross-section na yan, which is 25 mm ang height, and lapad niya is 130. And then, where does the shearing happen? Siyempre dito. And how many shear plane? Shear plane is 1 lang. Dito lang ang nag-shearing dyan. And then, saan nagbe-bearing? Pag humila to, saan hihiga ang bolt para hindi siya kumalas? So, dito nangyayari siya. Since identical yung plate, isa na lang ang check-in natin. So, ano yung mga limit states? So, meron tayong tensile yielding ng plate. Siyempre, since bolted, meron tayong tensile rupture, meron tayong bearing, and meron tayong shearing. So, let's do yung tensile yielding. Ay, unahin natin yung pinapakuha niya. Shearing muna. So, letter A, shearing muna tayo. Where does shearing happen? Dito sa mga bolts natin. So, P over A, since tatlo ang rivets, maghahati-hati yan ng force. P over 3, ganyan. So, this is, ano yung capacity? Ay, stress pa rin pinapaka. No capacity. So, ano yung, ano natin? P over 3. Isang ano lang i-check. Pwede na, pero pwede namang tatlo, pero kayong bahala. So, for me, isang bolt ang i-evaluate ko. So, ang load niya is P over 3. Over, ano yung area? Siyempre, area ng circle ng bolts. So, that is pi r, this diameter. So, r ang gagamitin ko is squared. So, substitute natin yung value ng P, which is 50 kN. Gagawin ko siyang Newton para consistent sa unit. Kasi ang diameter or radius natin is in mm. Para MPa ang lumabas. So, that is 50,000 divided by 3 over pi 10 squared. So, our shearing stress is equal to 53.05 MPa. Then next, pinapahanap niyo yung bearing stress between the plate and the rivet. So, eto, dito nagbe-bear. And the same, kukuha lang ako ng isa na i-checkan. Letter B, so, bearing stress tayo na. So, what is my actual? P over 3 over, ano ang bearing area? So, kung titingnan mo yung isang hole, so, pag humila to, humila doon, saan magbe-bear kapag may hila dito? So, dito magbe-bear. At ang area na kino-consider natin dyan is this one. This is the diameter ng bolt ninyo. And this is yung thickness ng plate, which is 25. So, substitute natin sa baba. Area natin is D. We have D. It is 20 mm. Ay, but 200. And then T is 25 mm. So, our P is STP. Substitute natin yung P. 50,000 divided by 3. 20, 25. So, our bearing stress is equal to, nasan na? 33.33 MPa. So, letter C, pinapakuha niya yung maximum average tensile stress in each plate. So, dalawa yung, tapos na tayo dito, tapos na dito. Dalawa ang pang-check natin ng tensile. May yielding at may rupture. So, unahan natin si tensile yielding, P over A. Ano ang P natin? Since nangyayari ang tensile yielding sa plate, diba? Dito ang nagte-tensile yielding kasi nandito yung force, dadaan yan, will cause tension, tensile yielding sa plate. So, ano yung area na yan? It is 25 and 130. So, P is buo niyang dadalhin. So, our tensile yielding area is yung buo, gross area. So, that is 130 times yung 25. So, that is equal to 15.385 MPa. And then, yung tension rupture naman, P over A, that is a net area. So, ano ang force dito? Hindi mo i-divide ang P kagaya dito, no? So, dito, dadaan ng buo ang force P, ang buong 50,000 Newton. Dahil, so, ito yung P natin, dadaan yan sa buong plate, at bago siya makapunta dun sa ibang bolts, dadaan muna siya ng buo dito, yung P. So, pagka punta niya dito, doon siya nabawasan. Dahil yung 1/3 na absorb na ng bolt. So, 2/3 na lang siya dito. Pag daan niya dito, doon siya magiging 1/3 na lang dito. Pero at this first section, ang tensile yielding force mo is yung buong 50,000 pa din. So, this is 50,000 over ano ang net area mo. Aalisin kasi natin yung area ng butas dahil sa bolt. That is yung gross area, which is 130 times 25. So, minus mo itong area ng bolt, 20 and thickness na 25 mm. So, this is, ang tension rupture is 18.18 MPa. So, ano ang mag-govern dyan? Siyempre, yung mas malaking load. Ito ang checkin mo. Kasi load yan eh, hindi yan strength, no? Load pa lang yan. Siyempre, you will design for the higher load. So, ito yung tensile mo. Ito yung sa shear. Ito yung stress mo sa bearing. So, timber, problem number 8. The timber member has a cross-sectional area of 1750 mm squared. Its modulus of elasticity is 12 GPa. Compute the change in the total length of the member after the loads shown are applied. So, kapag nakakita na tayo ng ganito, section, automatic yan. Section ka doon, then next, section ka dito. Pagtapos ka na dyan, section ka dito. So, at every point na may change, ibig sabihin yung mga yan, those causes change sa cross-section. So, kailangan mo section sa mga yon. So, gawin muna natin yung section A. So, to be in equilibrium, reaction ng CD ay 20 kilonewton din. So, for section B, so that will be isang buong ganyan. So, 20 kilonewton. And then dito, meron kang 35 kilonewton. To be in equilibrium, kailangan meron kang force na ganon. So, this is 15 kilonewton. Next. Dito naman tayo. This is C. So, dito, meron kang 20 kilonewton. And then, dito, meron kang 35 kilonewton. And then, dito sa point na to, meron kang 40 kilonewton. So, to be in equilibrium, ano dapat? So, to the right is 40 plus 20, so 60. Isa lang yung to the left, and it's only 35. Kulang pa siya. So, to be in equilibrium, you need 25 kilonewton dito. So, check natin yung mga internal forces. Dito, it's in tension. So, this is elongation. Expect mo ng elongation. Positive yan. Kapag dito, compression ang 15 kilonewton. So, contraction ka dito. And then, 25 kilonewton is tension. So, elongation ka dito. So, the problem wants us to get the total change in length niya. So, this is deformation. So, deformation, ito total natin from point A hanggang point D per segment. So, may tatlo tayong segment. So, deformation from A to D is equal to, ano ang formula natin sa deformation? Ay, Pilea. Tama. Pilea. Sanay lang away niya. So, this is for member CD. And then, for member, ano to? BC. And then, member AB. So, be mindful sa mga ano to? Sa sign nila mamaya. So, substitute na tayo. What is our P for CD? It is 20 positive. So, 20 kilonewton. I-convert ko into newton na. And its length is 3 meters. So, i-convert ko in mm. Kaya 3,000. And then, what is the E? This is a uniform in cross-section and also uniform in material. So, isang cross-section lang siya, which is this one. At isang E lang siya, or elastic modulus. So, isang E lang siya. Pwede nating ilabas yung E at A since consistent siya, no? Ilabas natin. 1 over EA. Para hindi na natin ulit-ulitin. Wala na tayong denominator. So, next, ano ang para sa section BC, it is negative. Negative tayo dyan. And it is 15 kilonewton. That is 15,000. Ang length niya ay 3 meters din. So, 3,000. And then next, ano ang sa section AB? 25 kilonewton na positive dahil tension. So, positive 25 kilonewton. So, that is 25,000. Ano ang length niya? It is 1.5 meters. So, 1.5 tayo dito. Okay, so, substitute E. E is 12 GPa. So, in MPa, that is 12,000 MPa. Para uniform units, dahil ito is in Newton, this one is in mm. So, ang ating MPa is in Newton per mm. So, what is our area? Uniform area tayo, which is this one, 1750 mm squared. So, doing the operation, so it's 2.5 mm. That is the total deformation. Next, ito naman, compound bar naman siya. Unlike yung sa kanina, uniform yung material kanina, dito magkaiba na. Aside from that, magkaiba na rin yung cross-section nito. So, example number 9, compound bar carries actual forces P and 2P and P. Find the maximum allowable value of P if the working stresses are 40 KSI for steel and then 20 KSI for aluminum. Total elongation also must not exceed 0.2 inches. So, tatlo yung kailangan nating isatisfy. Hindi pwedeng lumampas sa mga working stresses. Hindi rin pwedeng lumampas sa elongation. So, these are the limit states na pinapa-evaluate ng problem. Yung normal stress and yung deformation niya. And then, since sabi nga natin, may change sa bar, kailangan natin mag-section sa mga ganito. Let's check A. So, kung 2P ito, edi 2P din dito. And then, section ka sa B. Another P. So, to be in equilibrium, may 3P ka dito. So, parehas silang elongation dahil tension silang parehas. This is positive, elongation silang pareho. Okay, let's check yung normal stress na kaya ng mga material. So, normal stress na kaya ng steel is 40 KSI. Convert natin sa PSI para uniform ang units natin. So, 4,000 PSI. Then, stress is P over A. So, force over area. What is our P here? It is 2P. For steel, 2P siya. And then, our area is 0.4. So, uniform na ang units natin since PSI to and inches to. So, let's isolate P. So, 2P is 40,000 times 0.4 divided by 2. So, doing the operation, we get a P value of 8,000 pounds. So, ito yung kaya ng steel natin. Okay? Pag sa aluminum, so ano ang sa aluminum? 20 KSI. So, that is times 1,000. So, 20,000 PSI. So, force over area, ano ang P natin kay aluminum? It is 3P over, ano ang area ni aluminum? It is 0.6. So, isolate natin si P. So, 20,000 times 0.6 all over 3. Kasi may 3 doon na. Okay, so, we get a P value of 4,000 pounds. So, kukumpara mo yung dalawa, mas maliit na to. So, ito yung candidate for governing load P. Pero, kailangan natin i-satisfy din ito. Let's check ano ang makukuha nating P dito. Kailangan di rin mataas. Okay, so, this is our total elongation, which is 0.2 inches. So, ano ang elongation natin? For steel member, PLAE for steel plus PLAE for aluminum. Since different material, hindi natin pwedeng pagsamahin ang AE or yung kagaya ng ginawa natin kanina na inilabas siya sa equation since varying siya. Okay. So, substitute natin. For steel, ano yung load niya? It is 2P. 0.2 is 2P. Ito yun. 2P times ang length niya is 4 feet. So, gawin natin inches. So, times 12. And then, ano area niya? It is 0.4. Ang E niya is 29 times 10, 6 PSI. So, let's check check the unit. So, PSI to, this is in inch squared. Ito is inches na din dahil may times 12 na tayo. So uniform na tayo. And then, let's go to aluminum. Ang force ng aluminum is 3P. And then, its length is 3 feet. So, gawin nating inches. So, times 12. Ano ang area niya? It is 0.6. And then, ang E niya is 10 times 10 raised to 6 PSI. So, manipulate the equation. Isolate natin ang P. So, gawin natin mga coefficients na lang yung ito. So, solve for this one para maging coefficients na lang sila. And that is 2 times 4 times 12 all over 0.4 times 29 times 10 raised to 6. This is 8.27586 P. Wait. May ano siya. Times 10 negative 6 P. Plus, and what's this second? This is 3 times 12 all over 0.6 times 10 times 10 raised to 6. This is 1.8 times 10 raised to negative 5 P. So, pagsamahin natin yung P na yan, plus 8.27586 times 10 raised to negative 6. So, this is 0.2, 2.62756 times 10 raised to 5P. So, let's isolate P. P is equal to so, this is yung P para hindi ma-exceed yung limit naman ng deformation. So, comparing the 3P that we had, ito yung mag-govern. Hindi pwede mag-exceed dito dahil mag-fail ang ating stress sa aluminum. So, number 10 example, two 1.5 inch thick rubber pads are bonded to 3 steel plates to form the shear mount shown in the figure. Find the displacement of the middle plate when the 1-2 load is applied. Consider the deformation of the rubber only. So, ano-ano yung mga equation natin sa shear strain? Meron tayong shear stress is equal to G times gamma. Meron tayong equation for G which is E over 2, 1 plus Poisson's ratio. And then to get yung linear displacement, it is ito and times R. Okay, what we need, what the problem wants us to get is yung L. So, we need to find gamma and R. So, R, given yan dahil ito yung R natin, yung thickness na 1.75. If i-draw mo yan, ganito kasi yung mangyayaring linear displacement. Hihila to. Itong top ay fixed. So, magi-stay ito. Pag magi-stay yan, ito mag-move. This is free to move eh. Lalo na kasi malambot si rubber. So, mag-move siyang ganyan. Ito yung pinapahanap na L. And how would you draw itong diagram nito? This is your R. And then this is the gamma. So, R natin is 1.75 inches. Kaso, wala pa tayong gamma. So, let's find gamma. Meron tayong equation ni gamma dito. We can get G with this equation since given ang E at N. Pero wala tayong shearing stress. Pero may formula tayo ng shearing stress. P over A din yun. So, paano ang P over A natin dito? Diba, ito yung P natin. But since dalawa, ito, so magta-travel ang ating axial, half pupunta doon, half pupunta dito. then ko-connect doon. Tig half na lang ng P, 1/2 ng P dito. So, dito, 1/2 P tayo. And then, our area is, syempre, alin pa ba yung nagsishare? Syempre, malamang ito yung nakaglue niyan. Nakaglue itong buong area na to. That area is this one. Yung width na 5 inches and yung length na to 9 inches. So that is our area, 5 times 9. Okay, let's substitute. Our P is 1, 2, no? Substitute natin ang 1, 2 na load dito. We are able to get our shear. Our shear is equal to 13.335 PSI. So, pwede nating ilipat dito. But let's get G muna. G is E, and our E is 500 PSI. And then 2 over 1 plus N. Our N is 0.48. Our G is equal to 168.92 PSI. So, substitute na natin siya sa equation na to. And let's get gamma. Gamma, isolating gamma is shear stress over G. So, our shear stress is 13.335 PSI. And our G is 168.92 PSI. So, PSI parehas, so cancel. This unit will be, gamma will be in the unit of radian. So, our gamma is equal to 0.0789 radian. So, in radian, yan naman talaga ang unit kapag gagamitin mo ang formula na to. So, now we are able to get L, which is the linear displacement, times our R radius nga is 1.75. 1.75 in inches siya. So, ang unit ng linear displacement natin will also be in inches. So, itong displacement na to, sobrang maliit lang. 1381 inches. So, example number 12, the plastic sheet 1/2 thick. Ito yung plastic sheet, naka-enclose siya sa pin-jointed steel frame. So, mga pin ito, and then yung plastic sheet sa loob. Determine the magnitude ng force P that would result in a 0.18 inch horizontal displacement of bar AB. Since hindi naman, wala namang support or ankla to, yung point A and point B, it is free to move pag ganoon kapag may force P. So, anong magiging itsura ng ating displacement? So, ganyan. So, this is 0.18 inches. So, use modulus rigidity na 70 times 10 raised to 3 PSI for the plastic. Neglect the deformation of the steel frame. That means, hindi mo i-consider yung tensile yielding nito. Ganyan. So, let's just get this one. So, syempre, that is shear strain. So, the same. We will start sa formula na to. But this time, L is given, yung linear displacement, which is 0.18. Do we have R? Wala tayong gamma. R will be itong height na to, di ba? Kasi kung ito-drawing mo yan, nasan ang gamma dito? Ito yung shear na gamma, shear strain gamma. And then, ito yung L, ito yung R natin. That is 2 feet. So, paki-move lang natin to. Okay, so let's get gamma. Makukuha natin si gamma. 0.18 inches is equal to 2 feet. Times mo yan sa 12. Ba't ganun? Times mo sa 12 para inches. And then, makukuha natin si gamma. So, we get a gamma equal to 0.0075 radian. So, with this, how do we get yung magnitude na P? So, kailangan nating masatisfy yung shearing dito sa plastic sheet. Yun lang naman kasi yung pinapa-consider ng problem. Wala na yung ibang part pa. So, to get the shearing, kailangan nating masatisfy ang shearing ng plastic sheet para hindi siya mabiyak or mag-crack kapag nag-pull si force. So, ano yung isang equation natin? So, the stress, yung G, gamma. So, do we have G? It is given, si G. Do we have gamma? Nakuha na natin siya. So, makukuha natin si shearing stress. 70 times 10 PSI. PSI yung unit. And then, radian ang ating gamma. 0.075 radian. So, this is... So, ito yung shearing stress. Kailangan masatisfy ng plastic sheet. So, saan nangyayari ang shearing stress? Dito natin makukuha yung P. Dahil shearing stress is equal to force over area. Makukuha natin si Picasso, which is the shearing stress. Saan nangyayari ang ating shearing? So, ito yung force P. Let me erase muna. So, ito yung pin natin. Saan yan pupunta? Siyempre, doon sa anchor niya, which are the support. From dito, pupunta yan dito. So, kailangan masatisfy ng plastic sheet yung shearing stress na ginagawa ng P habang nagta-travel siya papunta sa support natin. So, ano ang ano ang shearing area natin dyan? Sabi nga, the shearing area is yung area na parallel sa line of action ng force mo. Ito yung line of force mo. So, ito yung area na parallel sa line of force mo. And that is, ito ang area na to, ang rectangle na yan is yung 3 feet and yung thickness ng plastic which is 1/2 inch. So, ito yung area natin sa denominator. So, what is our tau? I-substitute na natin sa baba. Ito, 525 PSI. And then, equal to, hinahanap natin ang shear or force P. And then, our area is 3 times 12. Para mag-inches siya. Kasi 3 is naka-fit pa. So, our P will be equal to 9,450 pounds. Ito yung P na masasatisfy ng plastic sheet natin para hindi siya mabasag, masira. So, last one is thermal stress. Meron pa ba? Simple thermal stress problem, no? So, ano yung mga equation natin sa thermal stress? Syempre, meron tayong yung elongation dahil sa thermal stress. That is yung alpha, delta T, and L. So, sabi dito, the bronze bar, this one, which is 3 meters, cross-sectional area is 350 mm squared, placed between two rigid walls at a temperature of -20. So, naging cold yan. So, contraction nangyari dyan. So, at temperature ng -20 degrees, nagkaroon ng gap na 2.2 mm. Ito siya. So, as shown sa figure, find the temperature at which the compressive stress in the bar will be 30 MPa. So, find the temperature at which the compressive stress in the bar will be 30 MPa. Ito yung alpha and ito yung G natin. So, the problem wants a compressive stress na 30 MPa. So, kapag may contraction na ganito, i-reach mo siya dito sa wall you're doing tensile stress. So, hindi yun ang hinahanap ng problem. Gusto niya compressive stress na 30 mm. Kailan mangyayari yun? Kapag mas mahaba ang bar natin kesa sa 3 meters plus this delta. So, pag mas mahaba siya kesa sa length na to, itong dalawa, pag mas mahaba siya, nako-compress, dun lang magkakaroon ng compression sa bar natin. So, ibig sabihin, kailangan natin i-increase ang temperature. So, paano natin malalaman yung corresponding increase in length para magkaroon ka ng 30 MPa na compression? So, punta tayo sa formula ng compression stress or normal stress. So, P over A. Ito ang gustong compression stress ng problem. So, ito yung 30 MPa. And then, may makukuha tayong P dyan, corresponding P. And then, P is part ng elongation equation na Pilea. So, pwede natin gamitin yun pag nakuha natin si P dito. And our A, is it given? Given siya, 350 mm squared. So, makukuha natin unit dito is in Newton. So, isolating P is equal to 10,500 Newton. So, pwede natin gamitin yung deformation equation na PLEA. Dahil nandito yung force. Dito kasi deformation siya, pero thermal deformation, hindi involve ang P dyan. This is deformation solely because of the change in temperature. So, dito natin ma-apply si P. So, what is the deformation? Kapag may P, this is 10,500 Newton. What is the length? It is 3 meters. So, gawin nating mm para consistent sa unit. And then is given, it is 80 gigapascal. Paano natin magagawang megapascal? Edi, mag-times ka ng 1,000. So, 80,000 MPa na yan. And then, area is 350. So, our deformation is equal to 1.125 mm. Okay. So, ito yung deformation only dahil sa compression. So, ito yung mas mahaba na yung bar. Ito kasi yung ito yung 1.125. Meron pa tayong kailangang isatisfy na to para bumalik yung bar into didikit dito para makompute naman kasi natin yung nandito niya. So, that means kailangan natin yung temperature na makakapagdikit doon. So, that is yung ito. And then, ano yung total na elongation na kailangan mo? It is 1.25 plus C delta. Kailangan natin mabuo ito. So, that is delta na 2.2. Delta is 2.2. Given yan dito. Plus si 1.125 equal to what is our alpha? It is 18 times 10 raised to 6 per degree Celsius. Yan. And then, what is our change in temperature? Ito yung hindi natin alam. Anong temperature natin mapapausog itong bar natin hanggang dito sa 1.125 na to. And then, L. What is the length? From a 3 meter length niya. So, gawin natin siyang mm. So, that is 3,000. So, isolate natin si delta T. Siya na lang naman yung unknown sa equation. So, our delta T, isolating. So, 3.325 ay delta T. 325 divide mo sa 18 times 10 raised to 6 times 3,000. Okay, so delta T is equal to 61.574 degrees Celsius. So, itong 61.574 degrees Celsius, ito yung temperature from the current situation na negative 20 degrees Celsius. So, tinatanong kasi ni problem, ano yung temperature mismo. So, kailangan ma-minusan mo pa. So, ang kailangan natin temperature is 41,574 degrees. Kailangan natin i-increase, ilagay ang temperature sa 41.574 degrees Celsius.